Get them out. Today we're looking at applications of natural exponential functions. Equations of natural applications, of natural exponential functions. Today everything is word problems. Yesterday we figured out what this new number e is. Ladies and gentlemen, what is e? Not quite 3. 2.71828. It is a button on your calculator, but not quite 3 is how we think of it. For graphing, it helps to think not quite 3. And it is a button on your calculator. You want to know how to use that button. It also took our formula, which we had compound interest, that formula from before last week, A equals P times 1 plus R over N to the NT. It basically took all this stuff in the middle and rewrites it with an E, because we found out that if you compound more and more and more frequently, we approach this number that we named E, a natural number E. And then the only thing we have to take into account then is that rate, whatever the rate happens to be, and T is time still. All right, find Q of 45. What does that mean if it says find Q of 45? Substitute 45 for T. You can see how they line up. Go to your Q function. We're going to plug 45 in place of T. So we have 1,000 e to the 0.4 times 45. And you need to put that into your calculator. So you all should have your calculators out, and you're plugging this in right now. And you're going to see if you get the same answer as I do. Because the hardest part here is plugging it into your calculator properly. Some of you it's really easy. If you have a Casio, it's a little more complicated. Okay. Good. So 6.5, I'd say 6.57 is a good-ish rounding answer. Approximately 6.57. If you did not get 6.57, tell me now. Didn't get it, did you? So in your Casio, you should be typing in 1,000 e to the, and then you need 0.4 times 45 in parentheses. You have to tell the Casio that all of those numbers need to be up in the exponent. Okay? All right. Okay, that's one. Yeah. All right, did you get it? Yeah? Okay.
Casio, is there 2 sets of C's in the exponents? Like one on the outside of the whole?
You don't, it's not necessary. There's lots of other ways you could write it. This is the easiest. Yeah. Yeah. All right. So again, using your calculator is the big thing. So that's what we're working with today. We have applications. Example 1. Find the amount accumulated from the investment. Example 1. Find the amount accumulated from the investment of $1,500 compounded continuously for 8 years at 3.5%. $1,500 compounded continuously for 8 years at 3.5%. Lots of word problems. We just wrote your test, which is like Monday, I think. You have a test on Monday. Yeah, you have a test on Monday. And it's like half word problems. Okay, so All right, so first of all, it says compounded continuously. And because it's using that wording, that tells me what formula to use. Compounded continuously is the PERT formula. So my model that I'm going to use is A equals P times E to the RT, the PERT model. Anytime you see compounded continuously, that's the PERT model. What do we put in place of P? Yeah, 1,500 is the principal, your starting amount. E is a button on your calculator. What do we put for R? No. No. 0.035. Remember, R is always as a decimal, so you need to convert it from the percentage. You need to divide by 100 or move the decimal 2 places. So R is 0.035. 0.035. And then what's T? 8. T equals 8 years. So 0.035 times the 8. Please plug that into your calculator. Make sure, this is the important part. Do you know how to use your calculator? And this is talking about money. So we're talking about $1,500. How much money do we have after 8 years? $1,984.69. Okay, this is the amount of money after 8 years. Not too bad. I mean, that's almost $500 extra that you did nothing for. All right. Letter B, $25,000 compounded continuously for 20 years at 4.9%. All right, it says compounded continuously. What model do we use? PERT model. A equals P times E to the RT. What is the principal? 25,000 is our starting amount of money. That's always the initial amount of money. And then times E to the, what is our R value? What? Point 0.049. Got to move the decimal 2 places. So 0.049 times T. What's T? 20 years. T is 20. So plug that into your calculator. Make sure you know how to plug it into your calculator. I cannot help you on this test with your calculator. All right, again, we're talking about money. We started with $25,000. How much money do we have after 20 years? $66,611.41. Good, 41 cents. All right. Did anyone not get that using their calculators? Okay. Any questions on those? Good, right? Compounding continuously uses PERT. That's a lot of money, right? Right? Oh my God. Dream. All right. Last one here. Example 2. Example 2. The number of grams Q of a certain radioactive substance. They're talking Q as they use Q as in quantity, if that makes sense to you. So the quantity of a radioactive substance, Q for quantity. The quantity of a certain radioactive substance present after T minutes is given by Q of T equals 500 e to the negative 0.2 T. How many grams remain at the end of 15 minutes. What do you suppose we need to do here? Substitute 15 for t. Yeah, they're giving you an equation, ladies and gentlemen. They're giving you the model. The only thing you have to know is what numbers go where. So we want to know the quantity after 15 minutes. So we are going to plug in 15 for t. So our quantity would be, using our model, 500 times e to the negative 0.2. And what are we putting in place of t? 15. So again, it's really, can you use your calculator? I don't know how many times I need to say this. On your test, can you take this test without a calculator?
Nope.
No, you cannot. You must have a calculator. Can you use your phone? No, you cannot. So, hey, let me ask you a question. What was the initial amount of radioactive substance? 500. Yes, this is always, whatever number is in front, that's how many we started with. We started with 500 bacteria, or not bacteria, 500 radioactive grams of some radioactive isotope. All right, how many do we have left after 15 minutes? 24.89 grams. What do you think is going to happen after 20 minutes? Are there going to be more or less? Less. Okay, because it's going down. It's decreasing. All right, so what do we need to do for 20 minutes? Yeah, t is 20. So plugging in 20. So the quantity, we started with 500. All right, so 500 e to the negative 0.2 times 20 minutes. No? 9.16. Okay, yeah. 9.16 grams. All right. Do you guys have any questions for me? What is the point today? Use the model. Use your calculator. That's the point. I expect to see this kind of work where you're writing down the equation. Okay, so I need to see on your work, you need to show me what you're typing and what the answer is. It's not too hard. It should be pretty easy.